This screencast is on the combined gas law, which combines Boyle's, Charles, and Gay-Lussac's law into one gas law. In the combined gas law, our variables are pressure, volume, and temperature. The only aspect that remains constant is the amount of gas. The rules we have to follow for the combined gas law are the same as those for Boyle's, Charles, and Gay-Lussac's laws. Pressure needs to be in the same units, volume needs to be in the same units, and temperature needs to be in Kelvin. This is the gas law where we will most often see the question asking about STP, or standard temperature and pressure. Recall from our previous screencast that standard temperature is 273 Kelvin, or 0 degrees Celsius, and standard pressure is 1 atmosphere, 101.3 kilopascals, 760 torr, 760 millimeters of mercury, or 14.7 psi. Let's take a look at the following problem. If I have 2.9 liters of gas and a pressure of 5 atmosphere and a temperature of 50 degrees Celsius, what would be the temperature of the gas if I decrease the volume of the gas to 2.4 liters and decrease the pressure to 3 atmospheres? I'm going to start by listing out my variables. P1 equals 5 atmospheres, V1 equals 2.9 liters, and T1 equals 50 degrees Celsius. When I convert that to Kelvin, I'm going to add 273 to it, so 273 plus 50 gives me 323 Kelvin. My second pressure is going to be 3 atmospheres. My second volume is 2.4 liters, and my second temperature is what I'm looking for. Let's plug those values into our equation. 5 atmospheres times 2.9 liters divided by 323 Kelvin is going to equal 3 atmospheres times 2.4 liters divided by x. Our first step to solve for x is to cross multiply. So I will have 5 times 2.9 times x equals 3 times 2.4 times 323. To solve for x, we're going to divide both sides by 5 and by 2.9. That cancels out the 5 and the 2.9 on the left side of the equation, leaving me with x. Finally, to solve, I take 3 times 2.4 times 323 divided by 5 divided by 2.9, and I get an answer of 160.4 Kelvin because I was looking for temperature. Read through and answer this practice problem. Add it to any notes that you have taken from this screencast. Submit your notes as well as the answer to this practice problem to Mrs. Benke, either as a paper copy or take a picture of your work and upload it onto Schoology.